Hi viewers, this is Mia Habib with the third video on my rock and mineral series, and the topic of this video is the amazing silica series. The term silica represent both silica sand and lump quartz. So when we say silica, it may be silica sand or it may be lump quartz as long as there is SiO2 is there. Silica sand is a sand made up of silica. Sand is nothing but a grain size. In engineering geology, all those particles ranging from 2 millimeter to 0.06 millimeter are called sand. But this sand is made up of quartz, that is silica, that is why we call it silica sand. Lump quartz is a massive form of silica. Our videos will be presented on both the silica sand as well as quartz. The topic are long, therefore, each topic will be divided into 5 parts. Each video will be 20 minutes each. So, on my left hand side you can see lump quartz. This was a big piece of quartz which has been broken into several pieces. On the right hand side it is silica sand. This silica sand is not processed, therefore, you can see there are black and brown and red grains of other minerals too. What is silica? Silica is silicon dioxide SiO2. Silicon Si is a natural element, but it is not found in nature. It is not found in nature. It is not found in the crustal rocks or anywhere on the earth's surface. When we say crustal rocks, crust is the outermost layer of the earth. All elements form from the crystallization of magma. What is magma? Magma is that lava which is inside the earth and which crystallizes and forms new minerals and rocks. When it comes out on the surface of the earth, it is called lava. So, all elements form from the crystallization of magma, and the same is with the silicon. When silicon crystallizes from magma, it immediately combines with oxygen and forms silicon dioxide or silica. Silicon Si has great affinity towards oxygen. It has great attraction towards oxygen, and it always combines with oxygen and forms silica. Silica also combines with many other elements, many other oxides to form silicates such as sodium silicate, potassium silicate, zirconium silicate, titanium silicate, aluminum silicate, etc. Silica, that is quartz, is the mother of all the minerals. You may not be agree with this, but I believe that silica is the mother of all the minerals. Silica and silicate rocks are the most abundant in our earth crust. The most common silica mineral, quartz, is the most durable, resistant to chemical breakdown. All minerals are breaking down on the surface of the earth. All rocks are breaking down on the surface of the earth. Some minerals and rock breaking down physically into smaller and smaller fragments. Some minerals are breaking down chemically into their components. For example, feldspars, they break down into their components chemically. Other silicate minerals such as K feldspar, potassium feldspar, which is KAlSi3O8, and soda feldspar, which is NaAlSi3O8, easily break down into their component during chemical breakdown, chemical weathering. K feldspar break down into one molecule of K2O, one molecule it break down into K2O, that is potash, Al2O3, that is alumina, and SiO2, that is silica. Sodium feldspar break down into Na2O, soda, Al2O3, alumina, and SiO2, silica. Quartz remains as quartz and it never breaks down chemically. However, it breaks down physically into smaller and smaller fragments of quartz. Quartz is the lone survivor on the surface of the earth after long periods of weathering and erosion. Actually, these terms weathering and erosion are very interesting, and we will have separate lecture about weathering and erosion. This weathering and erosion are the natural processes on the surface of the earth. Weathering is a process of breaking down. The rocks and minerals are breaking down. It may be physical, it may be chemical. And erosion means taking these broken minerals and rocks from one place to another place downwards, downslope, ultimately down to the oceans. And in geology, all these processes of breaking down and erosion, transportation from one place to another place by means of river, by means of wind, etc., it takes millions of years. The age of the earth is 4.5 billion years, and the oldest rocks found on the surface of the earth is 3.5 billion years. Therefore, in geology, thousands and millions of years is nothing. All the processes range in millions and millions of years. Free and combined silica. It is very important to understand what is free silica, what is combined silica. Quartz SiO2 is free silica, and it can be used in glass making because it is available as a free silica, or it can be used in any other industrial application. Silica present in potash feldspar is combined silica. You can see in this formula KAlSi3O8, or in this formula there is one molecule of potash, one molecule of alumina, 6 molecules of silica. This silica is combined with other molecules and forming a mineral which is called feldspar. So, this silica is not available for glass making. You can use feldspar in something, you can use feldspar in wherever you want to use, but you cannot take silica from this feldspar and use it in glass making or anywhere. The silica is combined with other molecules and cannot be liberated easily. So, silica combined with K2O, Al2O is not available for glass making. Silica sand versus lump quartz. Silica sand is made up of quartz grains ranging in size from 2 millimeter to 0.06 millimeter. This is the engineering geology definition. Lump quartz is like a massive form of silica, and it can be broken or crushed into required sizes. So, it is like a big chunk of rock, it can be crushed in the crusher, we can break it with a hammer, we can break it into smaller and smaller fragments. Now, my question is, please listen to this question carefully. My question is, if we take lump quartz and crush it in the crusher and screen it into the size from 2 millimeter to 0.06 millimeter, which is the size of the natural silica sand. So, I want to ask you, can we compare it with natural silica sand, and if we compare it with natural silica sand, what would be the difference between the two? So, you can imagine, because natural silica sand was formed from natural breakdown of quartz or other minerals, other rocks, and the quartz was traveling thousands and thousands of kilometers along with the rivers, with the wind, with glaciers. So, it becomes smaller and smaller and round and round. So, the natural sand, natural silica sand is always somewhat rounded because it formed as a result of weathering and erosion. On the other hand, this quartz which we crush in the crusher will have angular fragments, angular grains. It does not matter if it is a big grain or small grain, every grain will be an angular grain. Commercial resources of silica sand. There are many commercial resources. Silica sand is extracted from different resources. For example, beach sand, river sand, alluvial sand, dune sand, or sandstone. Here is the example of river sand. The river is accumulating sand into its delta. This is the beach sand. So, river the sea waves are dumping this sand along the seashore. This is alluvial sand. It has been transported by means of river or some other water, and it has been accumulated somewhere in form of alluvial sand. This is the dune sand or sand dune. People think that in Saudi Arabia and in other UAE countries, this is the dune sand which is used as industrial sand, but no, dune sand is never used, because dune sand consists of a large number of impurities. Dune sand consists of a lot of iron oxide, mica and other minerals, black minerals inside, and the sand grains are coated with iron oxide. So, the dune sand has no commercial value. Is the sandstone rock, which is the good source of silica sand. You can see its sandstone is flat sandstone, the outer surface is black because of the weathering. Weathering means the action of water and air on the outer surface of the rocks. The outer surface become black and sometimes browns, but when you break a fresh small piece, it will be white in color. So, sandstone is the main source in this region, in Pakistan, Saudi Arabia, UAE, Egypt and many other countries. Sandstone. Sandstone is a sedimentary rock. It consists of quartz grains of somewhat rounded shape, and quartz grains are bound together with a natural cementing material. The binding material may be a binding or natural cementing material may be kaolin clay, iron oxide, silica, calcium carbonate. So, what is the sandstone rock made up of? Because sandstone rock, if you break with the hammer, you will see there are sand grains, and if you see with the hand lens, the sand grains are somewhat rounded. They can be well rounded, but at least somewhat rounded, and these sand grains are bound together either by means of kaolin clay, by means of iron oxide, by means of silica, by means of calcium carbonate, etc., forming a rock. In some sandstone, the binding between the quartz grains is strong, and we need to use blasting to break the sandstone rock. In other cases, the binding between the sand grains is weak, and sand particles become loose just by touching with the hand or with the hammer. Such sandstone is called friable sandstone, and the miners look for such sandstones because it is easy to mine, it is easy to excavate. You do not have to blast it, you do not have to crush it. In some sandstone, the binding is very strong because silica itself is a binding material. Such sandstone is called quartzite or orthoquartzite. So, when the binding material binding between the sand grains is silica, so silica is a very strong binder, so it makes the strong rock, and that strong rock of silica sand, instead of sandstone, it is called quartzite or orthoquartzite. In fact, it is a sandstone, but it is very strong rock because of the silica binding material. Industrial silica sand. Industrial silica sand should be depleted in impurities. There should not be too many impurities in it, because removing many impurities is not economically viable. White in color, it should be white in color, loosely cemented, it should be easily A sandstone should be converted into loose silica sand easily just by initial blasting, easily to convert into sandstone into loose sand. Industrial sand should pass through wet processing that include washing, screening, attrition scrubbing and heavy mineral separation, and ultimately drying either under the sun or in the kiln. So, industrial silica sand is a processed silica sand. It is washed, and then not only washed with the water, it is scrubbed. The particles are rubbed together. So, the iron oxide around those grains and kaolin clay which is sticking on the grain, it should be removed, leaving behind nice and clean quartz grains. So, industrial sand should be processed, and for processing the best method is the wet processing. Some people do just some dry processing, they just screen it, but by screening you cannot produce high quality industrial silica sand. So, this is one of the silica sand processing plant. In this there is washing, attrition scrubbing, classification and finally drying. Silica sand processing. Although sometimes silica sand processing is a lengthy complicated process depending how pure you want your material to be. Sandstone is blasted to produce loose sand. So, sometime if the silica sand is friable sandstone, if the sandstone is a friable sandstone, by initial blasting all the sandstone will be converted into loose sand. But if it is little bit hard, by initial blasting there will be some chunks or boulders of sandstone left, and you have to send those boulders again for crushing. The loose silica sand is screened, sieved and oversized is sent for crushing again. It depends what size you want. Mostly in glass making people want a silica sand which range from 100 micron to 500 micron. So, the silica sand pass through the 500 micron sieve and then it pass through the 100 micron sieve, and the silica sand which stay between 500 and 100 micron is the required material, required sand for the glass making. Because all the impurities goes into silica sand which is finer than 100 micron. By the way, I think you should remember that in 1 millimeter there are 1000 microns. So, silica sand is washed at attrition scrub, heavy minerals are removed. There are heavy minerals like cadmium and titanium and many other minerals. These are heavy minerals. Silica sand which is quartz. Quartz has a density of 2.56. So, those minerals grains which are heavier than 2.56, these minerals are called heavy minerals. You can imagine that heavy minerals have high temperature, high melting temperature. So, when we are melting quartz grains, when we are melting silica sand for making glass, we add, as I told you, that to decrease the lowering temperature we add fluxing material. So, the melting temperature of quartz is about 1700 degrees centigrade. We mix feldspar or soda ash or nepheline cyanide into silica sand and brings the melting temperature down to 1250 degrees centigrade. Imagine if there were heavy minerals which has a high melting point, if there were grains of heavy minerals in the silica sand, and when we are melting silica sand, these grains of heavy minerals, they will not melt, they will stay there, and in the glass they will appear like clinkers. So, it is very important to remove heavy minerals. It is very important to remove coloring minerals. For example, copper and chromium, they add colors into silica sand. So, it is important to wash them to remove them. Industrial uses of silica sand, there are many industrial uses. We will discuss the important one. Glass making is the biggest industry of silica sand. There are several different kind of glass, low quality, high quality, very high quality. Silica flour production. Silica flour is a silica powder. Filtration sand for use for the filtration of drinking water, sewage water. Fused silica. Fracking sand used for the oil and gas, for the unconventional gas production. Casting sand. Silicon carbide production. Silica chemicals. When we produce silica chemicals such as sodium silicate is used to produce precipitated silica and silica gel. Silica sand is also used to produce colored bottle glass like beer bottles and some perfume bottles, etc. But to keep the consistency, we have to process the silica sand in good quality, and then we add the measured amount of coloring element into it. So, to keep the consistent color of the bottles. Structural glass. Structural glass is very fine, nice, clear, transparent glass used in the buildings. Automotive glass, solar glass, optical glass, borosilicate glass, recreational sand used for decoration, landscaping, swimming pool floor sand, poultry grit and play sand.